All right, so first we'll talk a little bit about HTTP. Can anyone tell me what HTTP is?
Hypertext transfer protocol. All right.
Yep. Yeah. So what is that? I mean, what does it mean, or what is that for?
Just a different protocol than FTP or Telnet or SSH. It's a protocol specifically designed to transfer between like a server and a client.
Okay. So what is a protocol? Someone else can answer. You don't have to answer.
It's like a form, an expected way of having information come in.
Yeah. So it's basically just a format. So a protocol is just, I expect to get certain kinds of information formatted in a specific kind of way. So HTTP is a protocol that someone made up, and then it just becomes standardized, and like most things on the web. So yeah, hypertext transfer protocol, so on. Yeah, it was originally designed as a protocol for transmitting hypertext. Hypertext meaning text that's linked to other text. So basically HTML and lots of other things. Okay. So HTTP kind of governs interaction between two different kinds of entities. You have a client and you have a server. So a client is basically whoever is initiating the request. So that could be, I'm using my web browser and I want to go to www.example.com. So I'm the client and my browser is the client making a request to a server. So that client server relationship can also extend. So you might have, from my browser, I make a request to another server, and then that server makes a request to another server. So in that context, a server could be a client to another server as well. Okay, so we've seen, and we'll see some more examples, but this is the request line, the first line of the HTTP request. The first item will be the verb, or the kind of request. So these are, the most common ones: get, post, put, and delete. And this is kind of paralleled by operations you can do on a database, right? You can fetch, you can run a query and get some information. You can insert information. You can update. You can do another insert, and you can also delete. So we've seen this, right? We have the get. This is the kind of request, and then here is the URI, or the specific resource we're going to, / whatever. And then here's the protocol, and then the version of the protocol. And the host, this is like basically the base URL of the server. And there's a number of other headers that you can have, including user agent, and you can have basically as many headers as you would like. And then requests have headers, responses also have headers. So if you make a valid request, that's valid according to the server, the server can send you a 200 response. And this is kind of like the text translation of that, okay. And the server will also send you a whole bunch of headers, depending on the exact needs of the application. But you can expect certain basic things like content type and content length. Okay, so we talked about this: the request line, the method, the URI. This is the specific resource on this server, example.com server, and then the protocol version. So you can look up, you know, what there's between URI, URN, and URL, and you'll be as confused as, even, you know, more confused than when you started. But essentially, yeah, it's one of those things where I'm sure there's a correct, precise definition, but people use it casually anyway. It's like whom in English, right? Does anyone know how to use whom correctly? And even if you do, it doesn't really matter because no one else does. So URI, this is, you can think of it as like the part after the this base, the base URL. Okay, and then requests can also have bodies. Here's an example of a post request. So we're making a post request to search, for example, and we're sending some information along. So this would, the server would be able to handle this information and act appropriately. And you can also use query param. So here's a GET request with basically the same information, but it's just sent in a slightly different format. So post request here, the information gets sent in the body. The GET request, this gets sent as query parameters as part of the URI. Okay, and there's just, you can look up information about headers. Yeah, so the format, so again, this is all basically text. So over the internet, everything is bytes, but when you're looking at it, you can think of it as text. So it's just a line of text, and then some headers, and then a blank line, and then some other stuff. So that's basically how you know your browser knows how to format, knows what sections of the message there are. Okay. Yeah, so here's.
Is there,
yeah.
Chad, I have a
Mhm.
quick question.
Sure.
Is there a way to tell the browser like what content type when you're making a request? Like if you're going to get JavaScript back or HTTP back?
HTML. So yeah, so I don't know if there's a way in, like, if you're using Chrome, if there's a way to do that. But if you're, for example, writing your own client, which you should be able to do in a couple days or maybe after today, you can set headers. And also, you know, if you're using a tool like Postman, for example, you can set headers. Now, whether the server, you know, listens to whatever headers you set is another question, but you can definitely set headers when you make a request.
Okay.
Chad, did we get a copy of these slides?
There's a link in the README for today.
Oh, okay. All right, thanks.
So yeah, here's some basic categories for status codes. So 200 is okay. That means basically everything went well. 300, the 300 series will be a redirect. 400 is the 400 series is you, the requester, did something wrong. And the 500 series is there's something wrong with the server. You don't need to memorize all of those, but it's probably a good idea to have this kind of level of knowledge, like 200, 300, 400, 500. Okay, yeah, so the client sends headers when it makes a request, and the server also responds with headers, and those headers could be a little bit different. So here's an example of setting a cookie. So this is, you know, cookies are really for for the server, not for the client. So the server sets a cookie with this set cookie header. The cookie gets created on the client, and then with every subsequent request to the server, that cookie is included. Okay. Yeah, so this is just right. So stateless. So the HTTP protocol is stateless, which means that every request is basically its own kind of self-contained interaction. So depending on what you're doing, that may or may not be what you want. So that's one reason why cookies exist. It's a way of kind of getting around the statelessness of the protocol. So you can keep information about the user, but at the end of the day, it is essentially a brand new request every time. Okay, so that's basically that's kind of just an overview kind of review of HTTP. Are there questions about that? All right, so let's see some
I have a quick question.
Yeah.
Is the local or you know what, I think I just answered it. The local storage, that's not sent over that to the server.
Correct. Yeah. So a cookie is basically something a server gives to a client for the sake of the server. Local storage is maybe something that code executing on a browser does for the sake of the local environment. So you wouldn't send information from local storage to a server. I mean, you could potentially, but that's not what it's for. Okay, so let's just we'll go. I'm going to use curl, so we know what curl is. I'm going to go to example.com, and I get a web page. So we're familiar with HTML, but we want to go a little bit deeper. So I'm going to give it a -v. So this is a verbose flag. So maybe I should use my window here. Let's try this. All right. Still good. All right, so curl. All right, so I make a request and I use the verbose tag so I can see more information about what's actually happening. So let's see. Anthony, can you tell me what this is?
So that was the GET request that you sent there, and it's telling us the host name, the user agent. I'm guessing that was your GET call. Did you use curl to do that?
Yep.
And then is this just like accept any parameters given or anything? I don't know what the accept statement is.
Yeah. So there's all kinds of headers. You don't need to worry about the specifics, but in general, like this whole thing is my request header. So
Okay.
when I make this client, so curl, it's a me or curl. Curl is obviously doing the real work, but when curl, which is a client, makes this request, it sends this. Okay, and then there's a new line, so the server knows that that's it. It's done. So it's not waiting for more headers or anything like that. Okay, so this new line is significant. It indicates the end of that transmission. And
So
yeah,
then that's the actual data that we wanted, or part of it.
So we have
Not really.
down here,
Yeah, that's just another header.
yeah, so this is another header, and where is this coming from?
Is that the response?
Yeah, exactly. So this is the server. So this first header, this is what the client is sending. So if you're on a browser, you know, Firefox or whatever you're using, you send a request. That first hit to the server is that's where this is coming from. And when the server responds, the server gets your request. It's listening for requests. It gets your request and says, "Oh, I just got a request," and then it sends a response. But it has to follow this protocol. It can't just send you, can't just send you whatever it wants. It has to follow this protocol, and the real meat of the protocol is this first line, where it says, "Okay, this is going to be an HTTP. Here's the protocol, and you sent me a request, and your request is good. And then here are a bunch of headers that I'm sending you. And then there's again, like a blank line. So the client knows that this part of the transmission is ended. And this next part is basically the content that we want. So you can think of this at the end of the day. I mean, this is what we really care about from like a user perspective. We have to go through this, and we'll see in a second, there's actually a lot more interactions happening. It's not just one request and then, sending one thing and then the client receives something and then that's it. Okay. So what I'm going to try to do now is I'm going to run a server. So Python has something called, well, it used to be called simple server, but it's a very simple server. I'm going to go ahead and run it. So let's see. So inside this folder, I just have not even an HTML file, just a text file with some text in it, hello world. So I'm going to run from within this folder. I'm going to run Python -m. I'm going to run it as a module, http.server. And I can specify a port. So I'm going to do 55999. So now I'm actually running a server here. So if I make a curl request, curl localhost 5995, was it
55999.
Thank you. I get this, so I need to be a little bit more specific. So it's saying here is so I need to give it a slash, give it a URI, so /index.txt. And then I get this response. So we're basically going to be doing something like that. We're not going to use this built-in Python. We'll actually be building one from lower level components, but I can keep making requests and keep getting a response. You can see here that I'm getting logs here. So someone made a GET request right here, and they get a 200 response. Try maybe making a POST request. So I get an error in this case. So the server is, being selective. So it's only going to accept certain kinds of methods. So this server won't accept POST methods, but you can obviously handle post requests in your own server if you choose to. Okay, so this response is purely just the way the server happens to do it. Okay. So I just want to show you a couple other tools just to, just to show that there's a lot more going on here. So the first thing I'm going to do is TCP dump. So I'm going to lecture. Okay, so I'm going to do sudo. So this is just a command line tool. And let me do first. Okay, so let me just try doing this first. TCP dump. Okay. Operation not permitted. So you have to give root level permission in order to run TCP dump. So that's sudo. And okay, sudo TCP dump. First thing I'm going to do is I'm going to you don't need to know how to do this. This is just kind of general background. List interfaces. This is going to show me all of basically everything that's available to me. And I have this right here. So does anyone know what loopback is?
Is that localhost?
Yes. Yeah. So this is localhost. So I can basically specify I want to listen to all the traffic that's on localhost. So I can do that here. So sudo TCP dump, and I can do -I for interface and LO0. If I do that, I'm going to get a whole bunch of stuff. I'm going to stop. And if I were to do this, just without even specifying, without being more specific, it would be way, way longer. So I'm going to specify the ports. So I'm running this on port 55999. So I'm going to listen here and then port 55999. So now I can actually get all of the traffic here that's on localhost port 55999. So now if I make a request, let me open up the tab. To curl. So I make a request here and I get a response. So that's good. But look what happened here. I got a whole bunch of stuff. So it looks very simple. When I make a request and I get a web page. And if you use verbose mode and curl, you can see that there's a little bit more happening. But here you can see that there's a lot more happening. So I'm gonna redo this and I'm gonna direct this to a file. So I'm going to run this. I'm going to make a request. And I should have a file here. I'm going to go ahead and stop this running. And I have this text file. So I apologize, this is hard to read, but so all we did is we made a very, very simple request, right? So I have this very simple server running and I made a very simple request and we got all this stuff. So you don't need, again, this is just general backgrounds. You don't need to memorize any of this. But here what's happening is, here is the sending party. So when I make a request, basically a random port on my computer gets chosen, in this case, 57961. and I'm trying to talk to localhost 55999. So this is our server here, right? So here's the client and here's the server. Actually, let me try something. Is okay, so just to make that slightly easier to read. So the client initiates a request, which makes sense, right? So I run that curl command and I say, hey, server, I would like to talk to you. So I send it. So there are a whole bunch of different kinds. There's like SYN and ACK. So it's an attempt to synchronize. Basically, it's initializing a request, and there's an acknowledgement of that, and there's some back and forth. So here's the initial kind of request to the server, and then the server responds to that initial request. So we are not at HTTP yet. We have no HTML. We don't have any document or text, or we're not getting any real content back. So my client initiates a request. The server responds and says, okay, I acknowledge that. And then there's some more interactions. And then here we have the client sending something. We can see the length here. So this is the content length, right? So, there's a content length header. So here we're getting the content length. So here's the first time that we're getting any like real substantive interaction from our perspective, since we only care about HTTP. So the client, so curl in our case, curl sent our server some information, 88 characters worth of information. Does anyone have any guesses what that might have been?
Might it include the address of what it's requesting?
Yes, it would include that.
Oh yeah, the header.
Yeah. So it's only here. So we've had 2 back and forths already, and here is the first header that the client is sending to the browser. Then the server basically acknowledges that, and then the server also sends something. It's longer, so it's 185 characters. Any guesses as to what the server is sending us here?
It's their response header.
header.
Yeah, it's right here. So there's the server response, and then the client acknowledges that, and then the client, sorry, the server sends something else to the client, which is 12 characters. So there's if you're counting, there's a new line in the file, so I apologize. So it would be 11.
Is this the one where we get the hello world response out of?
Yes.
Okay,
Yeah.
so that's the actual data we requested.
Mm-hmm. So that's here. And then the rest of this is basically closing out the connection. But you can see that there's a lot more going on. So you don't need to really know a whole lot about that, but just to give you some background, there's more happening.
I have a question, Chad. Perhaps you
Yeah.
already explained it. Why do servers have so many different IDs? Did you explain that already? Maybe I missed it.
IDs.
I mean, I'm just looking at the servers. It looks like, I don't know, maybe, okay, that's the client. I think before you changed it, did the servers have different numbers or something?
Yeah, so I changed this. I mean, yeah, that was a port number.
Oh, that's the port number. Okay, that's it. So whenever whenever it's, I guess, it processes, it just has a different port number. That's what it is.
Well, it'll actually keep the same. So this server is running on port 55999, so that won't change.
Okay,
But the client, when you make a request, you're also, doing it from a port on your own machine. It's just that the system usually just kind of randomly chooses one.
okay.
You can only have one connection per port per IP. So it has to change on the client side. Otherwise, if another application tries to talk to that port, it's not going to be able to set up a new listener on the same port. So you're going to see a lot of mixed ports generally on your client side.
Yeah.
Okay, thanks.
But the server shouldn't be switching. I mean, you could do that somehow, but the server really shouldn't be switching unless you're doing something kind of crazy. The server won't be switching ports.
Yeah, the server will always be the same. The client one's always going to be kind of messy.
And there are default.
Can you explain a little bit more about the ports? Like, how do we know which ports are valid ports to specify, and like, yeah, I guess just that.
Okay, yeah, good question. So there are, I don't know the exact number, 65,000 or something, approximately 65,000 possible ports that you can use. And some of them are reserved. Again, I don't know the exact, but something like maybe up the first 1,000 or so are reserved. But most ports are basically, it's a free for all. However, in practice, there are standard ports for things. So HTTP, the default port, the standard port is 80. So basically any unencrypted HTTP request that you make to a server will be on port 80. And then HTTPS is on port 443. Now why port 80 and port 443, I have no idea. That's just how it is. I don't know if was that and
Yeah,
was that an answer?
That helps. Yes,
Okay.
that helps. Thank you.
Okay.
So does that mean like we can't use port 80 and port 443?
You can. So if you wanted to run the server, we'll just stop it and we'll run it on port 80. You can do that. It's just kind of a convention. So if I go to some random web page on the internet, my browser is basically just going to assume that it's running on port 80 if it's unencrypted HTTP. You could do something wacky and just have your HTTP server running on port, 9023, but clients aren't going to be expecting that.
What command do you use in the terminal to get it to stop running if it's running? Is there a command?
Yeah, I'm just using Control C.
Oh, okay, thanks.
Okay. I also just want to show you one more thing, just more for the sake of interest. Just so there's this protocol, and it's also built on. There's actually a lot of layers beneath this, even so it's even more complicated than this. And of course, there are lots of nodes. So if I make a request to a server, it's not just going directly to the server. It's going through all these intermediaries. So you can actually see that there's another utility called trace route. And I'll go to this might take a second. So I just made a request to google.com, and it's basically telling me all the stops that it's making along the way. So most of this is the network. So Comcast, this is all Comcast stuff. And then probably, like, I'm guessing this one is Google. Let me just look this up. Block. Let me try this one too. Yeah, so Google owns that IP address. But you can see that there's a lot of, my request is going through a lot of intermediaries. So again, you don't need to really know that. It's more just general background information. All right, so I think that's more or less it for that. And then so the challenge for today. So I think I'll put you guys in pairs. So this particular series of challenges is controversial, and you might be the last class that does this. So you can either take that as good or bad, but you'll probably be the last class that does this challenge of building an HTTP server. So here's just some general notes about what you're kind of looking at. So the Python socket module, you'll have to look at this documentation, which is kind of shockingly unhelpful if you have no idea what you're doing. But there it is, the documentation. So this is it's a way of, it's got all these different pieces, and you can use them to build servers and other things. So basically, like it's basically like a file. A socket is basically like a kind of file. And the Python socket module is based on this, the Berkeley Sockets API, which is written in C for Unix systems, if you want to look at this. But there's kind of a core set of functions, like you create a socket, you bind it to a port, and this is from the server. So the server will listen to incoming requests. It can accept the request, and then it can receive information from the client, and it can send information to the client, and then it can close the connection. So here's so here are kind of some of the basic methods, and here is a diagram of the process. So on the server, you'll have to create a socket, you bind it to a port, you listen for incoming connections, and then you can accept a connection. And the client will also create a socket and then connect, and the server can receive that connection, or accept that connection, and then receive data from the client, and then process the request, do whatever, and then send a response to the client. So try to keep this big picture in mind as you get, lost in the details of the documentation. Here is the challenge. So you'll get some starter code, the server.py, which you should be able to run. And basically follow the instructions. And the end result will be, you should be able to handle 2 different kinds of requests. So this challenge is, I would consider it kind of like a bonus thing. And people find it very frustrating. So if you are frustrated by this, don't, it doesn't, I wouldn't read into that too much.